Hello and welcome to this exercise on area of a trapezium, in which you take in equations of lines, Pythagoras and surds and radicals. It is an iGCSE past exam question, and I think therefore suitable for. Sorry, it's an iGCSE additional mathematics question, and suitable for AS level mathematics and for high school algebra. And it says that solutions to this question by accurate drawing will not be accepted. So, and it says the points A, 4, 5, and B minus 2, 3, C, 1, 9, and D are the vertices of a trapezium in which BC is parallel to AD and angle BCD is 90 degrees. And it then goes on to say, find the area of the trapezium. Now, I know you're not supposed to draw this accurately. I've had a good guess of where the point should be, but I've also superimposed a grid because it helps you solve the problem yourself. If you make a mistake anywhere, you can go back to the grid and sort out your mistake, I think. Anyway, firstly, what we need to do is to find the height of the trapezium. In this case, the height of the trapezium is CD because CD is perpendicular to BC. Okay, right. To do that, we need to find the gradient of the line CB, and that would be 9, which is the y coordinate at the point C, minus 3, which is the y coordinate at the point B, divided by 1 minus negative 2, or 1 minus minus 2, and 1 being the x coordinate at the point C, and negative 2 or minus 2 is the x coordinate at the point B. So the gradient of the line CB is 2. Now, we need to find the equation of the line CD, and to do that, we need to find the gradient of the line CD, of the height. Because CD and BC are perpendicular to each other, therefore, the product of the gradients of CB and CD will be minus 1. So if the gradient of CB is 2, it then means that the gradient of CD will be minus 1 times a half, and that was minus a half, minus 1 half. Okay. Now, the equation of the line CD will then be y minus 9 because CB and CD share the common point C there. So the equation of the line CD is y minus 9 is equal to minus a half being the gradient of the line CD. So minus a half into x minus 1. And when we simplify, we end up with y is equal to 9.5 minus a half x. That is the equation of the line CD. Right. Now, for AD, we know that AD is parallel to CB. Therefore, they must have the same gradient. So, the equation of line AD will now be y minus 5 is equal to 2 into x minus 4, because the y coordinate at the point A is 5 and the x coordinate at the point A is 4. So the equation of the line AD will be y minus 5 is equal to 2 into x minus 4. When we simplify, we have that y is equal to 2x minus 3. Right. We now have the equation of we now have the equations of the lines CD and AD, and because they share a common point at D, so the coordinates at D will be common to both as well. So the y value of D will be common to both CD and AD. We then equate the 2x minus 3, which is the y value for AD, is equal to 9.5 minus a half x, which is the y value at D. Okay, right. When we simplify this, we end up with x equal to 5. So the x coordinate at the point D is 5. If we then substitute the value of x is equal to 5 in y is equal to 2x minus 3, we end up with y is equal to 7. So the coordinates of the point D would then be 5, 7. Okay. Now, we've got all the coordinates of the points. Now, we now need to find the lengths of various lines now. Firstly, we want to find the height CD, or the length of the line CD. Now, using Pythagoras, we do 9 minus 7 all squared plus 1 minus 5 all squared. Of course, 9 is the y coordinate at C, and 7 is the y coordinate at D. And similarly, we've got 1 and 5 for x coordinates there. And when we simplify, we have root 20, and of course 20 is 4 times 5, so root 4 is the square root of 4 is 2. So CD is now 2 root 5. That will be the height or the length of CD. Now we need to find the length of the line CB. Now similarly, using Pythagoras, the length of CB will be 9 minus 3 all squared plus 1 minus negative 2, or 1 minus minus 2 all squared. And that gives us root the square root of 45, which is 9 times 5, and the square root of 9 is 3. So the length of CB, or the height of the trapezium, the length of CB is 3 root 5. Okay, now for the length of AD, same thing again, using Pythagoras. The length of AD would be 7 minus 5 all squared, okay, plus 5 minus 4 all squared. And that gives us the square root of 5. Now, the area of a trapezium is the height times half the sum of the parallel sides. So the height is CD, the parallel sides are CB and AD. So we then have that 2 root 5, which is the height of the trapezium, CD, times half of the sum of 3 root 5 plus root 5. 3 root 5 being the length of CB, and root 5 being the length of AD. And of course, the 2's cancel out. So we now end up with the square root of 5 times the sum of 3 root 5 and root 5. Now, 3 root 5 plus 5 will give us 4 root 5. So we now have the square root of 5 times this 4 times the square root of 5. Of course, root 5 times root 5 will give us 5. And 4 times 5 will give us 20. So the area of the trapezium will be 20 units squared. And I hope all that made some sense, and please subscribe. Thank you for watching.